Oh my God, I just realized that I was muted this entire time. I'm sorry. Hi, everyone. My name is Phnam Bagley. I am a space architect and designer at Nonfiction, which is a design firm based in San Francisco. But before we jump into the actual presentation, I'm going to give an introduction of the organizers. So today's keynote is brought to you by BeyondSpace, a partnership with the American Center in Moscow. BeyondSpace is a 5-month virtual incubator and exchange program for students and early career professionals who are interested in developing new ideas for the space industry. Over the course of the program, participants work in teams to turn a space-related idea into a viable concept, learning from industry experts along the way. Today's keynote is open to the public because we believe great ideas should reach as many people as possible. Whether you're a BeyondSpace participant or part of the AMC audience, we're thrilled to have you here. All right, so thank you so much for joining us today. I know that we are live on a couple of platforms, so this is exciting. And as I am giving this presentation, I would like to invite all of you to put down questions in the chat, and hopefully we'll have enough time to answer all of them. But yeah, so today's keynote is on the subject of designing between Earth and space. And so I am what is called an industrial designer and a space architect. So I run a company called Nonfiction that I started with my partner about 10 years ago. And Nonfiction serves as a company that turns science fiction into reality. And so we work in many different industries that I'm going to go over a little bit later. But I act as creative director, meaning that I direct the creative process and the strategy that our designers and architects are working on for different clients. I call myself a space architect as well. So a space architect is someone who designs the built environments in which astronauts live and work, right? So I actually have a degree in that, which surprises a lot of people. I got my degree from the Sasakawa International Center for Space Architecture at the University of Houston about 20 years ago, which is pretty great. I moved to the US to study that from France, which is where I grew up. I'm also an industrial designer. So an industrial designer is someone who designs physical products for mass manufacturing. So think of everything that's around you, from your laptop, your phone, your mouse, your keyboard, your car, your shoes, your eyewear. All of these things are designed by industrial designers. On top of this official job that I just described to you, I have many side jobs. So there's an organization called XPRIZE, which was co-founded by Peter Diamandis, who you might know in the startup world. So I serve as a brain trust member, meaning I help XPRIZE come up with the competitions that are going to solve all the world's problems. So XPRIZE is instrumental in helping kick off the commercial space industry, solve a bunch of health problems, reduce carbon in the atmosphere and things like that. Another organization I'm very active in is OSMED, which is the Organization for Space Medicine, Engineering, and Design. And so I act as chair of design for OSMED for the first year and a half, and recently I just moved my role to lead of Project Orbital Hospital. So basically, I surround myself with some of the most brilliant space medicine experts, scientists, policymakers, engineers, designers, and architects to come up with the design of a hospital that could serve Earth, Moon, and Mars trajectories. Another role I have is with the Industrial Designers Society of America, where I serve as the jury chair of their IDA Awards. So IDA stands for International Design Excellence Awards. Actually, just came back from Detroit, where we're just deliberating these. So really, the work of the jury is to extract the latest and greatest and most extraordinary designs, from car design to consumer electronics to medical design and toys and such, out of an international competition that attracts people really pushing the boundaries of what design represents in this world. I'm also a board member of Side Exchange, which is an organization that connects STEM, which is science, engineering, technology, and math, and the arts, right? So how do we use the arts to talk about science, and how do we use science to talk about the arts, basically? And then finally, I also teach creativity and innovation to different organizations with an organization called Blue Courage. And so I teach, people in the military or law enforcement how to be creative for their personal and professional lives, which has been like very rewarding. I also work a lot with veteran organizations, and it's pretty incredible to see the transformation that happens when people know and understand what creativity can do for their lives. And as I'm a speaker today, I'm also a professional speaker. And between all the things that I do, I go on stage and talk about many different subjects, some related to design, some related to space, some related to health and well-being. So I've spoken at TED, I've spoken at South by Southwest, at COP, Expanse, and many other international talks. So this is a little bit about me. So you're given a little bit of context. So this is a little bit about the work that I've done. I've worked mainly in Silicon Valley design agencies for the vast majority of my career before I started nonfiction. And for those, I've been involved in many different quite famous brands that you might see on the right side. I was also a professor of industrial design at California College of the Arts, and have been involved in many different industries like we're about to talk about. But one thing that's very special about the life that I live is, yes, I'm a designer. Yes, I'm an architect. Yes, I work in earth space. But really what drives everything is my love for exploration. So I'm an avid traveler. I believe I've been to probably 50 countries by now. And I really like to be traveling to quite extreme places, underwater near the North Pole or near the South Pole, and in very remote places of Africa to really expand on my understanding of the humanity behind what we design, right? I believe that all communities from all over the world have something beautiful to offer. And instead of reading about it or watching documentaries about it, I like to go to those spaces and sit down with those people and have breakfast with them and really explore deeply the unique stories they have to offer, so I can translate them into the products that I design for the world. Because in the end, if I want to solve all the world's problems, I need to understand what the world is about, right? And the clean version or the sanitized version of what a society is just simply not enough for me. I think the difference between a good and a great design really comes from the subtlety in the details of what we put in the solutions we put out in the world. So, I've been to the tip of the South American continent, hiking with penguins. Last year, I went all the way north, about 900 kilometers away from the North Pole, to essentially live like an astronaut at a research station called Flashline for the Mars Society. I dove with turtles in Bali. I traveled in northern Australia to support local indigenous people and the work they've done in bush medicine research and how it can help astronauts. I've gone to conservation sites in Namibia, Southern Africa, to see what is being done with cheetahs, and different places like this. So it's a privilege to be traveling this much and to see such beauty in the world. Some of it is natural beauty, some of it is human beauty, and that exchange between what people have to offer the world of design and the innovation that I'm particularly interested in is really at the core of who I am as a designer. So one thing that's also very special about when I travel is, so I have the kind of brain that does not remember pictures. So I can take a million pictures and maybe remember 2 of them. However, I remember things that I paint forever. And so as I travel, I will sit down and paint portraits, or paint a beautiful tree, or paint a beautiful architecture, or the food that people eat. And there's this connection in my brain where I can smell and I can feel the time, I can feel the temperature, I can feel the moment at which this snapshot was captured. And so I have gotten in the habit of filling up countless watercolor books like these that you're seeing on screen. And I think it gives a lot of humanity in the work that I do, because a lot of work that I do is quite technologically advanced. And I think the bridge between the sensitivity of colors and textures and sensory experiences and the high technology that we all love and work for is quite special, and something that I've nurtured my entire life. So I was talking about all the different industries that I'm involved in. These are I would say, the top 5 that drive our company Nonfiction. So we work a lot in healthcare. So everything from, brain implants to cardiac devices to devices that remove tumors from bodies, to really work on every aspect of it. What's very great about working in medical is, one, the obvious positive impact that it has in saving people's lives and increasing their quality of life, but also the rigor that comes with creating medical devices, right? In the United States, we have to go through the Food and Drug Administration guidelines to make sure that whatever you put out there, one, does something and doesn't hurt people. So that rigor to me is so incredibly important to integrate, not only in the medical industry, but in every aspect of the industries that we work for. So since we're here and we're hosted by BeyondSpace, my work in aerospace is pretty prominent as well. I have a very unique voice in the world of space, as I think a lot of people who get in the space industry are fall in love with that world and have dreamt of being an astronaut and were inspired by all those things. I actually came into the space industry out of frustration, which is very interesting. So I would grow up and see all this, I would say Mir, which is this famous space station from when I was growing up, and the space shuttle, and now the ISS, and seeing all these environments not necessarily designed for humans, right? They were designed for exploration, they were designed for survival, very engineered to survive, not necessarily to live comfortably, or certainly not to thrive. And so I really wanted the space industry to make that jump, and that's how I got into it. And so the whole space medicine, human performance, sensory design, food, all these aspects that seem so secondary or tertiary to the space industry are exactly what I want to focus on. I'm going to talk a little bit about that later. I've designed with my team a very large amount of wearables. So everything from transformative technology, everything related to sleep, longevity, physical performance, mental performance, reduction of brain, brain inflammation and things like that. There's incredible technology that is being developed non-invasively to help not only inform people about their own well-being, but giving them agency over it, which is pretty incredible to live in the time where we can do that. We don't have to open people up and try things out to see if a therapy is going to work. Climate technology is big in what we do. Working a lot with super low-cost renewable energy, sustainable architecture, food technology, and we're also involved in river and ocean cleaning, which is, I think, as citizens of the world, we should be aware of and participate as much as we can. And then finally, consumer electronics, and that was a little bit earlier in my career. Before I started Nonfiction, I've designed every audio, computer, phone products you can think of. That part of my career was very useful in understanding what it takes to design mass manufactured products, because I think a lot of people out there have beautiful ideas, very noble ideas on saving the world and making it better for everyone, but not everybody necessarily knows how to go about a project and push it all the way to launch and success on the market. So I was taught that early, and now I'm applying these methodologies to all the industries I'm involved with. So as Nonfiction, the company I started about 10 years ago, we started as a classic industrial design firm, right? Like basically saying yes to any client that came our way, wanted us to redesign their product, and that was fine. And about 3-4 years in, that's when we decided to solely focus on positive impact. And so there are sort of 3 conditions to work with us. We only work on innovation like never seen before. So that's why we get involved a lot with, skunk works at big corporations or agencies that are looking to do a lot of research, or we go after, all the universities, research labs. So we work with Rice University, Yale, Harvard, MIT, all those people. UC Berkeley, UCSF, incredible researchers and professors there are needing people like us to translate all of their scientific breakthroughs into products that people actually love to use, right? So you can actually see the impact of their discovery. Number 2 is the Sustainable Development Goals. So these are 17 goals put together by the United Nations, I believe in 2015. And so basically thinking about what good can we do in the world? How can we end poverty? Can we end hunger? Can we protect life on Earth and underwater? Can we increase access to education? Can we make health accessible to all, right? All of these goals that should be honestly pretty standard in developing new technologies out there. And then finally, one point that's quite important to me that I wish more people focused on is a path to execution and success. Because as I said earlier, a lot of people have great ideas. If you sit down at a dinner table with your families, your friends, you'll probably come up with 20 wonderful ideas about how to make the world a better place. But really the execution and what it takes to make that real, what kind of funding, what kind of team, what kind of methodologies, what kind of partners do you put in a room to make that happen is integral to the story that we put together. So one thing that's very special about the way I see design, because unlike a lot of designers, to me, design is not the end goal. Design is just a tool for the end goal, and the end goal is creating a beautiful tomorrow, right? And to me, also, design cannot do this alone. Design is wonderful at fostering connection. However, it cannot do anything unless there's business, science, technology, and art in the room. Because to me, business enables change, right? Puts together teams and budgets and guidelines and understand what is needed now for us to align with. Science, every time I talk to a scientist, it just sounds like what they do is magic. The type of breakthroughs that they discover and the types of links that they validate through experimentations. It's just like every day is new and interesting and beautiful. Technology, being based in Silicon Valley, I get exposed to the latest and greatest in technology, and so the enabler of possibility. And I love the fact that we are able to understand what these technologies are working on and be able to translate them into designs that mean something to the people it's designed for. And then finally, art. I think art is often put aside as a nice to have, but without art we don't have emotion, and without emotion it's very hard to connect with your end user, right? So to me, there's a balance between design, art, technology, science, and business to create the goal of it all, which is meaningful innovation in order to create positive impacts in this world. The method, because of all the work that I do, and I'm involved in so many projects at a time and all that, like we can't use, I would say, traditional methodologies to do it. And so there's a process called the Lean Product Development process. I believe it was put together by Toyota a few decades ago, but it's really the idea of not working in a handoff process. So the handoff process is when you have multiple teams, like the design team, the engineering team, manufacturing team, sustaining operations team, that separate themselves, do the work they need to do, and then hand off to the next team. The problem with that is that you run into extended timelines. The risks go higher because there might be a difference in translation of information. Decision making is very haphazard. Maybe someone makes a decision but has not communicated to the right team, and then the vision goes all over the place. Very rarely, when you use that methodology, does the design intent of the beginning end up towards the end. And so when we use lean product development, which is essentially the overlapping of disciplines working together hand in hand, making decisions together, you actually mitigate all of these risks I just mentioned. So it is not for everyone to do. It's not necessarily comfortable for engineers to talk to designers, for example, or vice versa, but it is something that I do impose with all of our partners and teams, because I see the difference in the outcome when you work this way. And when you know how to work this way properly, it's actually quite fun and beautiful to see these synergies happen where they're most unexpected. This is just like a very high level view of like how we process we create our process. So we pretty much always work in 5 stages, always research and definition first. Essentially, what are we doing for whom and why? And as you can see, the design tasks and engineering tasks are always overlapping. I never, ever have designers work in a vacuum. I always have the engineers or the business people or the policy people in the room to understand how we align. And without that in the beginning, I can almost guarantee disaster down the line. And then conceptual design is going to be very important, like really imagining, how far we can go and what kind of details are going to put all this together in a way that is understandable by all team members and down the line by the user. Product architecture is when engineering and design is going to work very, very closely together. So detail by detail, solving all the physical and behavioral puzzles that turn a conceptual design into a real product. Design refinement is quite important because a lot of the times when you work on so many details, you tend to forget the 10,000 foot view of what the product should do and what it should be about. And that's when you run a lot into feature creep, a lot of great intentions that actually don't mean anything in the field. So testing is going to be very important here. The testing is going to be done at another level in phase 5, where we deliver a design in different forms of prototypes. It can be ergonomic prototype, it can be cosmetic prototype, it can be functional and cosmetic prototype, depending on who we're working with. But testing it in the hands of the people it's designed for, in the environments they're supposed to live in, is so incredibly important before we go into any other process. So now that I've done, a little bit of a introduction of like how we work as a company, I'm going to give you a few examples of how we practice all this. So buckle up, because we're going to start in space and eventually we're going to go on the body. We're going to go inside of the body and then back in space again. So when you're exposed to the work that I do and the work that my team does, it's very explorative, right? Because to me, people who work in very narrow industries tend to do the same thing again and again. And they become very good at it, but they're not necessarily exploring the edge of what that industry can offer. And because we're traveling in and out of the body on and off Earth, it recalibrates the assumptions that we make as designers, and it helps us come up with ideas that are rich in intellectual property and the emotion that I was talking about, the art that really makes each product so incredibly unique. And so that's what we offer to our clients, like something that really touches them in ways that engineering alone could not do, or business alone could not do. And that is the magic of design. So I'm going to talk about this first project, a small company you might have heard of, Sierra Space, which is based in Colorado. So a few years ago, we helped them outfit the life module which stands for Large Integrated Flexible Environment. So basically, it's a inflatable structure with a hard core where the life support system sits that is docked to a commercial space station. And so this, module was developed specifically for at the time Blue Origin's orbital reef, which was a program for one of the first commercial space stations. As you may know, Blue Origin is now focusing more a little bit on lunar surface targets due to NASA's focus. But at the time, it was something that was quite novel and pretty incredible. So the idea was to have these modules, which are about 8.2, 8.3 meters in diameters, to host different commercial astronauts, perhaps scientists coming from pharmaceutical companies who need to do some work in microgravity, or there could be some tourists or other types of workers that need that specific environment for a number of months at a time. And one thing that we wanted to do in these environments, coming back to my comments earlier about what got me into the space industry, the last thing I wanted is for this beautiful concept of an inflatable structure to look exactly like the International Space Station, right? Which is very functional, very stark, very basically designed for professional astronauts to go about operations all day long. However, when you talk about non-professional astronauts, perhaps scientists or technologists, roboticists, researchers of different kinds, they may have a very different relationship to, the role of an astronaut. But one thing that most of us have in common is a love and an understanding of the beauty of nature. And so I really wanted to take a lot of the natural colors and textures and proportions, the neuroaesthetics of it all. The neuroaesthetics is basically the science of how the brain and our nervous system absorbs art and beauty around us. And so that's really the relationship that we have with nature. And so extracting all of this, giving it names and giving it some specifications is where we started. And then eventually we started building all of these environments in which these scientists, astronauts would live and work, right? As you may know, if you live in microgravity, you have to work out about 2 hours a day, every day, and you usually do this alone. Otherwise, you throw off the orbit of the space station, which is a very fun fact. But if you look at the way people are working out currently aboard the ISS, it's quite boring. It's not necessarily motivating. However, if you integrate projection mapping or AR or VR, haptic, feedback loop and things like that, you can actually make these 2 hours of working out so much more pleasant and so much healthier to be around. You can create fake sense of advancement by having wind blow into your face on your body. And so working out with that motivation is not only great for maintaining muscle and bone mass, but also great for mental health, right? Because you're isolated up there, because you don't have access to your colleague, your family, and all your loved ones, really any aspect of supporting your circadian rhythm, your nervous system, your microbiome, and all that is going to be so incredibly important. So doing that with the inspiration and of nature is one way we wanted to do it. On the right side is kind of like developing a little bit about how we design best work environments for all of these scientific experiments, perhaps like manufacturing in space, that is conducive to a calm, productive environment. Because if you have stuff everywhere on every single wall and nothing is particularly organized in a way that works for you, mentally, it's going to trigger cognitive overload, and it's going to be very difficult for all of you to for the people working there to be effective at work. And same thing for other aspects, how you go to the bathroom, how you look out the cupola to look at how beautiful our planet Earth is, how you create safe but also very comforting private quarters. When the astronauts sleep, what kind of colors and textures or reminiscence of perhaps underwater calm can be projected in these environments to support the health and well-being in their private time. So there was a 1-to-1 scale prototype built of this life module for Sierra Space. And you can see it here at the NASA Marshall Space Flight Center. And if you want to go on YouTube and see what it looks like when it explodes, it's actually a very, very cool video. Unfortunately, I could not show it here, but this is what it looks like in the process of being exploded as air is being pumped in the inflatable structure to its limits. All right, so now we've been in space. Let's go back to Earth. So nature is, because I travel the world, because I have a love of nature, because I think there's no better engineer than nature itself. And us human engineers are trying really hard to copy or to mimic what's going on in nature, but we're still so far behind. But there are certain steps that we can do in between. And this is an example of it. So a few years ago, I was involved with a company called Human Headphones, and so Human Inc. And then we designed something together called Human Headphones. And so basically, Human Headphones is an ode to natural design, because when you look at nature, nothing is a straight line. Nothing has a perfect radius. Nothing has a perfect flat surface. Nothing has buttons or flashing LED lights or screens or anything like this. And so when we're trying to force things like our smartphones onto our bodies, there's something quite unnatural about that synergy between our human body and these electronics. However, if we redefine the geometry and the design of the technology that we put on our body, especially when the part of the body is the ear comes in such a variety of shapes and sensitivities. You might have different sizes of the ear between your left and the right, and certainly when you look around the room, everybody has different sizes of types of ears. And so how do you design something that is so incredibly organic and complementary to the fractals of the human geometry, but also fits most adult ears and applies the technology that you want to apply? So here the technology is headphones. It also works as a speaker and translator of 11 languages in real time. So it's quite advanced technology. And as I said earlier, nature doesn't have buttons. So why should we have buttons on the technology? So here on the right side, you see the gentleman sliding his finger on the outside to control volume, next song, right song. All he has to do is slide his finger. And so these are some of the very interesting kind of innovation that we came in the behavior that we have with the audio products that we integrate into our lives. The clipping system to each ear was incredibly difficult to develop, as you can imagine, as ears come in different sizes and sensitivities, and we want to make sure that it fits all the components. So there were a lot of components that were custom. We had to do extensive 3D printing to make sure that we had a geometry that fit most adult ears. And so this exercise took about 6-7 months for us to end up in a geometry that actually made sense. And it surprises a lot of people when I tell them that this came out 8 years ago. It's a product that launched before the pandemic. And yeah, it was a complete feat in design. Nothing like this has been done since, which is pretty extraordinary. And it's nice to be part of a team that understands that in order for such advancements in design to happen, you have to have all of these disciplines work together. Because if you just have designers in one room doing this shape, it will look completely different. If you just have engineers, it will look different. If you just have human factors designers or scientists, it will look completely different. But if you have all of these people working together, using tools like 3D modeling, 3D printing, and integration of custom components working together every day, making decisions together, you end up with a shape that is so incredibly, sensual and beautiful and doesn't overload, people visually. So this was really, really fun to work on. The next one is a product that's quite extraordinary. So all of us sleep, but very few of us actually sleep well, right? And there are many reasons for that. Stress, the environment in which we sleep in, things we might have on our mind, and things like that. So But once you understand that sleep is actually a neurological state, and it can be healthy and unhealthy based on the type of brain waves that your brain goes throughout the night, then you can do something about it. And so here we work with professors and research scientists from UC Berkeley at a company called STEM Science, and we developed this device that is actually two different devices. So you have the band, and on the band you have EEG sensors. What it does is that it reads the brain waves before, during, and after sleep, right? You have the alpha, beta, gamma, delta brain waves that have certain signatures throughout the night that say whether you are in N1, N2, N3, or deep sleep. A healthy sleep is when you go through these 4 phases 4 to 5 times a night. If you use devices like Oura Ring or other like sleep tracking devices, you can see, the same sort of like pattern of sleep pattern happening 4 to 5 times a night. However, when your sleep is disturbed, you might not experience enough deep sleep, which is the part of the night where the excess information is being removed from your brain, and you wake up very, very groggy and tired. And so one thing that the scientists of STEM Science did that's extraordinary is that they found that the 15 minutes before sleep, there's a very specific pattern of brain waves that kicks off healthy sleep. And that is why the little part on top is. So you have the band with EEG, and then you have a little part on top. The little part on top has 2 electrodes that electrically stimulates the prefrontal cortex to tell your brain what patterns to follow 15 minutes before sleep. So in that state of drowsiness, it follows this pattern, and then the rest of the night, the brain knows what to do. And that is something that is quite incredible about the state of medicine today. For a long time, we have designed medicines to fix the symptoms, but not necessarily think about the root cause of why the symptom even appeared, right? And the solution might have been like quite invasive, surgery, medication, and things like that, but doesn't really fix the problem. When you take a sleeping pill, I don't know what they are in Russia, but in the US, we have Ambien, which is very common. Ambien basically shuts down your brain, but it does not let your brain rest, which is why you're so tired the next day. Whereas a product like this will tell your brain what to do for 15 minutes and then have your healthy brain follow a pattern of brain waves the rest of the night that is healthy. And so by the next morning, you are refreshed, you are focused, and you can go about your day. And so this product is so incredibly effective that it's if some of our like people on our team at Nonfiction actually were beta testers of this device and got almost overnight good night sleeps on a regular basis. So it's pretty nice to see that technology that sounds so simple can actually change people's life, because sleep is more than just rest. It's more than just spending a third of your life in bed. It's actually related to how you act during the day, your circadian rhythm, your mood is affected by it, your effectiveness at work, your focus. And so if you can treat that through sleep, that's honestly half of the work during the day. And here you can see a little bit of like the design. Internally, we have people who were fabricating the prototypes by hand. We wanted to use silk, which is this beautiful natural material. It's a temperature regulator. It slides on the pillow, so it doesn't like get caught on your pillow and move the technology throughout the night. It is very luxurious as well to live around. So really that sensitive multi-sensory experience of integrating technology in your life, but not bringing down the level of human experience is the balance that we like to bring there. And you can also notice that the design is not just super clean or like very consumer electronic. It's quite sensual and natural. There are like gradients of different colors, of silhouettes of mountains. The charger actually looks like a riverbed. So all taking inspiration from nature and how it helps us regulate is really expressed in the industrial design of this device. Next one is also a brain stimulator, but it does something a little bit different. So there are some scientists that come out of University of California, San Francisco, that figured out that if you stimulate your motor cortex, which is on top of your head right here, in a very specific way using electricity, transcranial electricity, you can actually get in what's called the state of flow. So the state of flow is when, for example, when you're running and you're not thinking about running anymore, you just do it, right? The brain has the ability to really have you focus on that rather than be distracted and feel like the running is a chore. And so we can, with this kind of product, you can get there in about 20 minutes and sustain that state of flow for about 4 hours. Because what happens when you work with athletes or people who work out a lot is that they get peak performance when they stay in that state of flow much longer during training. And so this device was originally designed for athletes. And we realized that anybody who uses the motor skills, whether they're athletes or musicians or dancers or anybody else, can actually benefit from staying in that state of flow much, much longer. And so this was paired with an app. But one thing that was very interesting about the work that we did with this team is that we tried really hard to bring down the cost and elevate the user experience, right? We wanted it to be comfortable, whether you have hair, no hair, you're sweating a lot or not. The device is actually very comfortable. Those little nibs that are touching your motor cortex on top are actually quite flexible, and can help with integrating this device into your life. And we gave it a form factor of a headphones because nobody wants to go to the gym or to training with something weird on their head, right? I think the discretion of integrating such technology into something that's familiar, that also, because it's a form factor of a headphone, it creates the right even pressure around the head and helps with the electrodes stimulating the brain properly. So yeah, it's I think at the time this product was sold for about $350 and it sold so well that the company got acquired by a Swedish company called Flow Neuroscience, which is basically using the same technology but applying it for depression patients. So pretty cool to see that. And so you can see here it's been used by athletes here, USA Olympic athletes using it in their training, which is pretty cool. I work a lot in neuroscience, and there are many different ways we can use like non-invasive technology to make people's lives better. This one I'm particularly excited about. We're still in development. We just finished our first clinical trial to incredible success. So there's a professor at UCSF who basically is developing technology that applies a very specific magnetic field. It's called microtesla magnetic therapy around the brain. So it's basically a magnetic field that goes around the brain but doesn't touch the head. And what it does is that it applies that magnetic field and then creates a whole biological cascade in the body, starting in the brain, that helps with reducing brain inflammation. As you may know, a lot of what's wrong with our health as humans comes from inflammation. Inflammation can come from the microbiome. It can come from an infection. It can come from autoimmune diseases or things like that. So if you reduce brain inflammation, you can actually help the body heal itself much faster. If you can go online and typing what the clinical trial was about, but some of the extraordinary results that we got is not only did it help people suffering from autoimmune diseases like long COVID, which is what it was designed for originally, but it also helped with different aspects of depression and anxiety. So there's a lot of comorbidities, physical and psychological, that really make it difficult for a lot of these people who suffer from these conditions to, one, be diagnosed, and two, be treated properly. And so this device has the promise of doing those two things just by using it about 15 minutes a day, every day. You don't feel anything. And we design it in a way that really, is very inviting, but also beautiful and unique. And it fits most heads because of the flexible parts of the parts that touch the head that you can see here. So it was really, really fun to work on this. We also had partners that worked closely with us to create prototypes. And you can see me testing one of the first prototypes on the head, making sure that the head was actually sitting in the middle of the halo, which is very important for the effectiveness of the product. So it's pretty great to work on such incredibly technology that can save the lives of so many people, and being able to give it a form factor that has never really been seen before. So it's such a privilege to be there. Now that we've talked a lot about neurotechnology outside the body, let's talk about inside of the body. So we are involved a little bit in implantables, brain-computer interaction, and this one is specifically designed for people suffering from treatment-resistant depression. So treatment-resistant depression is when you suffer from depression, but you've tried medication, talk therapy, and all the classic changes that doctors recommend you, and nothing works. Right? These are people who contemplate suicide on a daily basis and don't know what to do. There are some therapies out there that are effective, but they're not particularly convenient for people suffering from depression. For example, TMS, which is transcranial magnetic stimulation, is basically going to the hospital for a number of days, taking time out of your work, your work schedule, sitting at a chair, having this device put on your head, and you sitting there for a number of hours during the day, right? And the effects of it are very, very promising. Helps a lot of people get increase their mood and all that. However, as I said, it's not really convenient, and a lot of people actually bypass this very effective therapy just because of the inconvenience of it. And so what we're doing here is that we're taking that sort of same technology, but applying it to a brain implant. So you can see on the top left part, it's a brain implant that was developed by Motif Neurotech, which is out of Rice University in Houston. And basically it fits in the thickness of the skull, so it doesn't invade in the brain tissue, and it applies similar therapy as what I just talked to you about in the hospital. What is great about this is that it's very small due to the fact that there's no battery in it. The battery is actually integrated in a hat that you wear on the outside, and all you have to do is align the charging system with the brain implant, and then the brain implant can do its job. What's great about this is that you can do this from home. You can do this, as you're walking outside. And one of the greatest, most important things about this type of therapy is maintenance, right? You might spend 5 days doing extreme reversal of your mood or of your condition with depression, but then it will come back in about a month or two. So having a brain implant, having a hat system that you can have at home, being able to be dosed on a regular basis, enough maintenance therapy to keep you off of this depressive state is really the difference between an effective therapy and one that is not. So that is what we're working on. And it's pretty extraordinary to be working directly with people who suffer from these conditions and understanding what is going to work for them versus what we think designers is going to work for them. And there's a difference between the two, right? As a designer, most of what we do is very based on assumptions. So we jump all over that. So I'm going to go a little bit faster now because I realize that we don't have that much time left. But we were involved in humanoid robotics, which are very hot right now. Designing like heads that fits in different environments. We're working in logistics. We're also developing robots currently for assisted living. We're also involved in helping companies tell the story of how to take a very, very big robots like this and turn it into something very small, so small that it can be swallowed. So a doctor on the other side of the planet can tell you what's wrong with your esophagus or your stomach, perhaps diagnose you with an ulcer or a cancer and get you to the hospital as quickly as possible from there. We'll also work with augmented reality for firefighters. So one thing that you never see in movies is how the visibility in burning building is pretty bad. And so having a augmented reality lens inside of your oxygen mask, as well as a thermal camera on the outside, is going to be helpful for firefighters to see what's going on in real life. So the technology essentially gives you the edge of everything, the edge of walls, of ceilings, of stairs, of furniture, of people, and helps these firefighters see through smoke in real time and be able to save lives much faster, including their own. So very, very much involved in extreme environments, right? We've also designed computers for companies like Intel, very elegant ways to deal with thermals of such powerful small computers, making sure that the colors and all that really integrate into people's homes or professional environments. One of my many lives in the past, I was very much involved in luxury goods. So I was trained in traditional leather crafting by a woman who used to work at Hermes. So everything is handmade. A lot of people ask me, so you work in all this like incredible technology, like why are you involved in luxury? And I'm like, I think there's a lot of overlap between craftsmanship. When you design a rocket, when you design like a bespoke space environment, there's a lot of craft in it. Sure, you're using machines to do it, but understanding how two parts come together, how they last forever, how they're designed for repair, how they're supposed to integrate with the human behaviors and culture is so incredibly important. And I think the world of luxury teaches us a lot about that. And because I was born and raised in Paris, luxury and the cultural code of luxury and understanding what it takes to make a luxurious product is something that's not necessarily obvious in other cultures. So being able to bring that to the conversation makes it quite rich and interesting. So yeah, I was involved in designing 3 different collections under my own brand for this. We're talking earlier about climate technology. So we developed this microarchitecture that collects solar energy in villages in Nigeria and Tanzania. We're actually involved in supervising the manufacturing of the first one in Lagos, Nigeria. And we also designed this like series of batteries, super low cost batteries. So the villagers in those places don't have enough money to even buy a battery to charge up their phones, to tune into their stereos, plug into their TV if they have one. And so it's a whole system where they get to rent the batteries for, depending on the region, $3 to $5 a month. And they can swap them as quickly, as often as they want. And this is not only microarchitectural work or industrial design work of these batteries, it's also kind of like a cultural shift work that we're doing. So the company that is putting all this together is called Jazza, and they employ 100% young women to do operations. So these women, typically around the age of 17, 18, finish school, maybe expected to be, married mothers and stay at home once they reach that age, are actually given the opportunity to make a living, a very good living. They're taught skills of customer service and all of the skills that are going to help them not only as individuals, but also as community leaders. And so seeing that transformation coming from a technology that we made available for them, the economics of it, and also the design of it is pretty extraordinary to watch. So I was there with my team, supervising the manufacturing of things, the installation of the very first of these prototypes in Oyo State, Nigeria. It was 1,000,000 degrees outside. You can see I'm like dying of heat in this picture, but there's nothing like seeing the first customers and the joy on their face when they see that this access to renewable energy at an affordable cost is available to them. Involved also in food and space, work with NASA on this basically space kitchen that works for microgravity on like deep space missions to Mars, for example. So we create this like microgravity garden using aeroponics. We had a bioreactor that grew microalgae for food, basically like highly nutritious food that has the potential of protecting cells from high level radiation, which will be a problem when we go to Mars. We also had the space barbecue because we realized that grilled proteins are very much integral to a lot of celebrations in a lot of cultures, and so we wanted to offer that to the astronauts as well. However, open fire is very, very dangerous in space in an oxygen-rich environment that is all enclosed, and so we decide to use lasers to create those like grill marks on the chicken that you see on the top right, and that actually completely changes our perception of the food from something that's just designed for sustenance versus something that's designed for culture and pleasure. The last thing I want to cover is, me going to the Arctic and testing a lot of these things in an extreme environment. So it took us, it was supposed to take us 4 days to get to Devon Island, which is the largest uninhabited island on planet Earth, which exists there. And we go there because there's a massive crater that can give us a lot of information on how to best have a space habitat at the edge of a crater on the surface of Mars and do some research there. But I was crew commander of Crew 17 of the Mars Society expeditions. And 4 of us integrating a lot of the textures and cultures and food and art to make life in this extreme environment, very isolated from the rest of the Earth, with communication delay with Earth, a lot more pleasant, so we can focus on the work that we have to do for operations, survival, and getting the work done in terms of research. So privileged to have been doing this. So yeah, I'm going to stop it here. But thank you so much for hearing me talk about all this. This is a lot, and I think this is time for questions. Okay, I see comments here. Comment from Daria. Your travels are so impressive. Question from Natalia. Thank you. Question from Natalia. What is your IP strategy in industrial design? In other words, what is the role of your lawyers, patent attorney in this sphere? So when we invent things in design, it is the law here to have our names on the design patents. Sometimes we're involved in the utility patents as well if we've invented a certain mechanism. So yeah, it's pretty common. Question from Andrew. SDGs are everywhere now, and with enough skills, almost any project can be framed as SDG friendly. How do you distinguish meaningful innovation from superficial branding? It's subjective, isn't it? No, it's not. The impact is really can be quantified, qualified, and depending on what it is, what the technology does, who it's for, there's a difference. Greenwashing is a real thing, and I mean, to someone like me who works in it all the time, is pretty obvious usually. Question from Natalia: what is your favorite invention in industrial design? I don't have a favorite. It's like they're all my children. I think each of the stories I shared with you today is unique, and it's a translation of the interest I have and the curiosity I have about the world. I don't think medical is more important than aerospace is more important than other things. I think there's a time and a place for everything. And I think what's beautiful about the work that I've been involved in is the fact that I've been privileged enough to have a foot in everything, which gives me perspective and doesn't necessarily make me an expert in any of those things, but gives me enough information to translate to other industries. Because when you think about innovation, it's rarely invention that comes from nowhere. It's often an innovation that comes from somewhere else that's been translated in a way that means something new to you in this new industry. The question: what mindset do you think is most important for someone who wants to help shape the future of human life in space? I think interdisciplinary collaboration, open-mindedness, and patience. These are three things that are essential. I think experts and subject matter experts are still very valuable in space. However, they're not necessarily translators, right? They're the people you come to get answers to the science technology questions that you might have, but your translators, whether they are builders, engineers, designers, policymakers, these are people who implement and know how to make the links that nobody else can. That was the last question. We can switch to Zoom. Okay, thank you so much, everyone. I hope to see you soon.